Yesterday, we were looking at polygons' interior angles. And we found that there was a formula for finding the sum of said interior angles. It was 180 times n minus 2, where n was the number of sides. But interior angles aren't the only type of angles that we'll deal with on these shapes. So one of the things you're going to have to pay attention to is where is the angle located. Interior angles are the angles on the inside of the shape. Exterior angles are the other type of angles that we're going to be dealing with today. An exterior angle is an angle outside of the polygon created from extending one of the sides and making a linear pair with the interior angle. Now, we dealt with exterior angles when we had triangles. We had a triangle, and it was the one where all of a sudden one of the sides got extended. And that extension with the side made the exterior angle. And we had the triangle exterior angle theorem from it. But general polygons don't use that formula. General polygons, when you look at their exterior angles, you got a different situation going on. So, we have the polygon exterior angle theorem today. Polygon exterior angle theorem states that the sum of the measures of the exterior angles of a convex polygon, one angle being at each vertex, is 360. Note that it doesn't mention anything about how many sides, because it doesn't matter. The number of sides is irrelevant for exterior angles. If you have exterior angles on the shape, one at each corner of the shape, they add up to 360. So let's say this is angle 1, this is angle 2, this is angle 3, this is angle 4, this is angle 5, because this happens to be a 5-sided polygon. What's the name of a 5-sided polygon, by the way?
You think the polygon?
I might have stuttered a little bit. It's a pentagon. The sum of each of those angles is 360. So measure of angle 1, plus measure of angle 2, plus measure of angle 3, plus measure of angle 4, plus measure of angle 5, equals 360. And it's always 360 for exterior angles. So, with this we can solve for x. I got this shape here. Now it doesn't matter how many sides it has for this theorem, but I'm still going to ask it. This one has 4 sides. What's the name of a 4-sided polygon? Quadrilateral. So this quadrilateral has a bunch of angles. Do you notice they're on the outside of the shape? Do you notice that there is one at each corner of the shape? Therefore, they are exterior angles, and this formula applies that says I can add them all up and set it equal to 360. Much like with interior angles, one of the most common mistakes I see is people missing angles or accidentally double counting them. So it's not a bad idea to put that little dot by which one you start by and then go either clockwise or counterclockwise around. I prefer clockwise. Yeah, calculators are good things. Grab one if you need one. So 6x plus 9x plus 2x plus 139 equals 360. Aiden, if I want to solve that, what would you tell me to do first? Combine my like terms. 6x plus 9x plus 2x. 17x. Still plus 139 equals 360. If that was a proof, what would that step have actually been called? Say it louder. Simplify. Okay. Brody, what would you tell me to do next? Subtract 139 from both sides. If this was a proof, would it be called subtract? Yeah. 17x equals 221? Yep. Sweet. Nate, I want to solve. What would you tell me to do next? Divide by 17. If this was a proof, would it be called divide? Yeah. X equals. I'm guessing it's like 13.
Yeah, 13.
Sweet. Is that what the question asked for? Yes. What if it asked you to find the measure of each exterior angle? You would plug it back in. It didn't ask that, but it could ask that. Trap B on your own. I will be coming around to check on them when I got it done myself. You do the first. That's a beautiful. Love it. Fantastic. Yeah. Well, that one matches these up. done with notes yet.
We should,
We have another page yet.
I think we should not. I got all these two, right? To get that?
Yeah, that's all you should get.
Well.
That's a freak.
Oh,
562.
why is there not? 255. Where's that piece?
Yes, it's always 260. Yeah, we don't have to worry about speed. Okay, we should be sitting in our assigned seat, please.
Can I go get water now?
Yes, ma'am.
Can you get some water?
Okay. So I believe I got a chance to check with everyone. We got x is equal to 19. The laptop away. But that is not the only thing we're doing today. We are doing the next page. So, exterior angles add up to 360. Makes for a pretty straightforward formula. The other thing that we will run across today.
What?
You don't have to kill pencil. The other thing you're going to run across today is it talking about a polygon that has all congruent sides and all congruent angles. It's known as a regular polygon. A regular polygon is the polygons you generally think of when you think of your polygons. Because back in elementary school, when someone mentioned triangle, they probably started off by drawing one that looked like this. And if they mentioned quadrilateral, they drew a square. And if they mentioned pentagon, they drew one that looked perfectly, as best as I can draw it, like that. But those are not the only triangles, quadrilaterals, and pentagons out there. I can draw triangles that look like that. I could draw quadrilaterals that look like that. I could draw pentagons that look like that. They look a little funny. These funny looking ones are not regular polygons. The ones that have all congruent sides and all congruent angles are the regular polygons. That's what we most think of when it comes to this. Now, if you have a regular polygon in which all of its sides and all of its angles are congruent, that means you can find each individual interior angle and each individual exterior angle without having to have all of this stuff notated around or inside. Because all of those angles are going to be the same. So to do this, the first thing we have to do is we have to find the sum of, well, are we doing interior or exterior? In this case, it wants both. So we're going to start by finding the sum of the interior angles. If only there was a formula for the sum of the interior angles of a hexagon. Oh wait, there's a formula from yesterday for the sum of the interior angles, isn't there? 180 times n minus 2. What's n? 6. Because a hexagon has 6 sides. Did I hear 720? It is 720. Now that gives me the sum of the angles. That's all of the interior angles added up. How many interior angles does a hexagon have? 6. The number of sides and the number of angles are equal on every single polygon. 5 sides means 5 angles. 100 sides means 100 angles, etc. If this is what they are all added together and they're all the same, how could I find an individual one? Divide by the number of sides. I take the sum, divide by number of sides. I'm going to write that down. That's my little step on how do I get that. If it's a regular polygon, it has to be a regular polygon for this to work. My instructions tell me it's regular. So in this case, 720 divided by 6. 120 degrees. And that was the interior angles. Did we answer the question? Not fully, because it asked for each individual interior angle as well as each individual exterior angle. Thankfully, much of the process is similar. We find the sum of the exterior angles. Now this is easier, because what is the sum of the exterior angles of every single polygon in existence? You don't have to do any math for it. It's 360. And if I want to find an individual angle, I take the sum and I divide it by the number of sides. In this case, 360 divided by 6. 360 divided by 6? 60. And that's the exterior angles. So that's another type of problem you're going to see today. Got a couple more examples of it. Next one's a 20-gon. I want to find the sum of the interior angles. Kylie, what would you tell me to do? 180 times 20 minus 2. Yeah, what do we end up getting? 3,240. So that's the interior angle sum. Charlie, how do I find an individual angle now? Divided by the number of sides. 3,240. 240, if I write it correctly. Divided by, how many sides were there? 20. It's 20 gon. Means 20 sides. ion, what do we get?
162.
162 degrees. Now, please do mark that that is an interior angle versus an exterior angle, because there's two answers I'm looking for. I want to know which one's interior, which one's exterior. I do the same thing for the sum of the exterior angles and finding it. Except, that's even easier. Because Lauren, what does every exterior angle add up to on every single polygon? 360. And so I take 360 and divide it by what number? 20. And we get 18. Now, before we get to our final one that looks like this, and then we change up the instructions, I want to point something out to you about this little pattern that can help you out with these. I want you to look at questions A and questions B and see if you notice the relationship between the interior and the exterior angles. Those two together and those two together. What did you notice, Jackson?
You add them together and you get like how the thingy, angle. I can't remember the word.
Add both the
Like 60 or 120 and 60. Yeah, equal 180.
They add up to 180. So you're going for the word supplementary?
Yeah.
They are supplementary. But here's the thing, they should be supplementary because an interior angle and an exterior angle form a linear pair, and linear pairs are always supplementary. These two should always add up to 180. It's a quick double check that you did something right, or if you didn't. Now keep in mind that these numbers are not always going to be nice, pretty numbers. Round to a single decimal place if you have to round. Okay, we got one more like this and then we're changing it up. Mariana, how would you like me to start this process with the 61 gun? Gotta find the sum of the interior. You don't actually have to write this out, but for the notes, I found it helpful. And how do we do that, Mariana?
180 and then 61 minus 2.
Beautiful. Cam, what do you end up with?
What?
What is the sum of the interior angles of a 61 gon?
10,600.
Beautiful. Ava, what do we do with that now?
You divide it by number of sides.
How many sides are there?
16.
Now notice it's not gonna round nicely every time. Keep one decimal place, so it will be 174 point. Would it be 0 or would it be 1?
1.
Remember with rounding. That's better. There we go. Remember with rounding. If you want to round to a single decimal place, you not only have to look at the first decimal place, you have to look at the decimal place after it. That's the one I want to keep until, but the decimal place after it. Is that 5 or bigger?
Yeah.
If it is 5 or bigger, then it tells you that the number right before it has to increase by 1. That has to increase. So 174.1. Make sure you mark that as interior. Even if you just write int, you don't even have to do the angle symbol, but it just tells me it's the interior one. Diego, how do I find the exterior one? I'm sorry, I didn't hear you.
By dividing 61.
Dividing by 61, dividing what by 61?
No, 174.
No, and you missed this piece. You came in a little bit late. The sum of the exterior angles is always the exact same number, and it is always 360. So, my bad. You came in a little bit late on that one, so. For exteriors, always 360. Then we divide by 61. Found it properly, what would we get? 5.9. Question for you. Do those two add up to 180? Yes. Sweet, we did things right. Okay. Last thing you're going to see is working a little bit backwards. But it's also a fairly easy concept. Given the sum of the measures of the interior angles of the convex polygon, find the number of sides. In other words, this right here, that's the sum. What's the formula for sum of the interior angles? We've been using it already today. We used it yesterday. 180 parentheses and minus 2. In other words, 1440 equals 180 parentheses and minus 2. And it wants you to solve.
So, how are we gonna get the answer? What is the end of it?
You're solving for n. Peyton, if I want to solve for n, what would you tell me to do first?
Divide 1440 by 180.
Yes. But most people would not do it that way. In my personal opinion, it's the easier way to do it. I'm not going to write that way down because that's going to mess with some people. There are two ways to solve this. I find the way that Peyton's describing easier, but I find it easier because I do a lot of math like this. Most of you probably wouldn't do that first. Jackson, if you saw a problem like this, what would you do first? Most people would distribute. $180 times n is really easy. It's 180 n. 180 times 2 is 360. Aria, what would you tell me to do then?
Or what?
To solve this.
Don't you have to divide 180 by 360?
Nope. You're overthinking it. I'm just trying to solve for n. I need to get rid of the 360 and the 180. Which one goes first? If this is being multiplied and this is being subtracted.
Add the 360 to the 1004.
Yeah, you're overthinking it. 1880 equals 180 n. I would divide by 180. Jada, what do I end up with? 10. N equals 10. Now, it says find the number of sides. Did we solve the question? Is n a number of sides? Yes, it is. N is the number of sides. This is what it's looking for. But, for the sake of argument, what is a 10-sided polygon called? A decagon. It's on the front of your packet. got two more. Piper. I'm giving a sum of 18,900. What would you tell me to do?
Put 18,900 equals 180 parentheses and minus 2.
Beautiful, love it. Haley, Bakken. I have this right now. I want to solve it. What would you tell me to do? You see the parentheses, what do you do over here? What do I do over here? Distribute. We've distributed this before. It's 180 and minus 360. Haley Hurt. Now what? Add 360. And then divide by 180. N is 107. If I asked you what the name of this polygon is, what would you tell me? 107 gone. Now the actual answer is n equals 107, but it is a 107 gone. Yes.
Can't you just divide their number by 180?
Yes, most people that messes with them. That's why I just don't do it that way. But yes.
That's the way I started doing it first.
Yep, and that's the way that Peyton was describing as well. Yes, you can absolutely do it that way if that's the way that you see it. Most people don't see the 180 parentheses and minus 2 as anything other than distribute. That's why I don't generally do it that way. But, yes, absolutely. If I'm doing it myself, that's my plan of action. Yes. Oh. When you finish the last problem? Yes. Because guess what I'm going to tell you to do on the last one? Try it on your own.